Okay, so in this video, we're going to be multiplying and dividing radical expressions. So first off, if I have nth root of a and nth root of b and I'm multiplying them, in this situation, okay, they have to have the same value here to be able to multiply them, and then we can multiply those numbers regularly, how we normally would do. Okay, so I'm going to change this one to a 3. Okay, so in this first one, because they aren't the same, we cannot do it. We cannot bring them together to simplify. My answer would just stay like that. Okay, my next one, they are the same, so I would take 6 times 2 to get to 12, and then I would see if I can simplify it. Is there anything that when I cube it, it gets me 12? There isn't anything, so we're just going to leave our answer like this. Okay, my next one, they aren't the same, so we can't do it. My next one, they are the same, so we're going to multiply and get to 10, and then I try to think, is there anything that when I take it to the 5th power gets me to 10? Well, I got 1 and 2. 2 already bumps over 10 when I do 2 times 2 times 2 times 2 5 times, so we're just going to leave our answer like this. Okay, let's list off and all of our squares and all of our cubes. So when I do this, my squares, it's going to be, when we're talking about this, answers that are going to be in the square root form. Okay, so if I take 1 squared, I get 1, 2 squared is 4, 3 squared is 9, 5 squared is 25. Okay, and then I'm just going to write the rest out super quick here. Okay, so here are all your options. Make sure you write them somewhere you're going to remember them, or somewhere where you can see them, because we're going to be using these the rest of the time. And then we're going to do cubes. So 1 cubed is 1. 2 cubed is 8, so 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. Then we got 125 and 216, 343, and 512. Okay, so these we're going to be using when we see problems with cube roots. Okay, so we're simplifying these. This time they're not so pretty. I can't just take the cube root of x to the 5th, because normally when I was dividing, I was doing 5 divided by 3. Well, that gives me a decimal. So this is how you do it if it doesn't square root pretty, like in a pretty way. So what I have to do is I need to get rid of the cube root. So I need to get rid of some sort of cube in here. So what I need to do is look at what I did on the last one, and that was all the ones that I've cubed. So if I go back, which one of these can be divided out of 54? Okay, 27 actually can be divided out of 54, because 27 times 2 gets me 54. So if I rewrite it, I have 27 times 2, and then I have 5 x's. And I'm going to group my x's by the number out here, so 3. I pull out the number of groups, so there's only one group of x's that came out, and there's 2 left in there. Okay, I can now simplify what's underneath here. So the cube root of 27 is 3, because 3 times 3 times 3 gets me 27, and then I have a 2 left. Another way that you can do it, instead of writing out all the x's, 5 divided by 3, 3 can go into 5 2 times. Okay, so I at least have, or 3 can go into 5 1 time. So I at least have one x on the outside because it can go into it once. If it does go into it once, I should have 2 left. Because 5 minus 3 is 2. I would have 2 left after I take that one group of 3 out. Okay, so if I move over here, the cube root of 128, there's nothing that when I cube it gets me 128 super pretty. So I go back and figure out which one of these 128 can be divided by. And we're doing cube root again, so I need to make sure I'm looking at my cubes. Okay, so 64 times 2... 64 times 2 gets me 128. So I have 64 times 2, and then I have 7 x's. If I'm writing it out the long way, the cube root of 64 is 4. I still have a 2 on the inside. I'm going to move that 4 over. This was supposed to have a cube root on it. Boop. Okay. If I was doing the grouping method, I would group them by 3's again, because it's a 3 sitting out here and I wanted 3, so I have 2 sets that came out and I have 1 that's left. Otherwise, what you could do is, well, 3 can go into 7 2 times, okay, so that means there should be 2 on the outside, and then if it goes into it 2 times, that means I'll have 1 left, because 7 minus 6 gives me 1, which is why there's 1 left on the inside, because I pulled 2 groups out and there's only 1 x left. Okay, now if I look at these problems, remember, if I have an odd on the outside, so an odd root out here, my answers we leave the same. If it's even, remember we put the absolute values in it. My next one, we can multiply regularly, so we're just going to go multiply it. 72 times 10 is 720. X cubed times x is x to the 4th. Y squared times y cubed is y to the 5th. And now we're going to simplify it. So I can't take the square root of 720 and get a pretty number. Remember, this is a little 2 out here. So I'm going to go back, and this time I'm going to look at my squares column. So which one of these is divisible by 720? So which one can I divide out of 720? And then this is guess and check. So I would take 720 divided by 196, 720 divided by 144. And actually 144 is the one that works. Okay, so 144 times 5 gets me 720. So 144 times 5, I have 4 x's if I'm writing it out the long way, and 5 y's. Okay, so the square root of 144 is 12. I have a 5 left on the inside. I'm grouping by 2's this time. And I'm grouping by 2's. So I have 2 x's that came out, 2 y's that came out, and then I have 1 y left. Otherwise, what you could see is 4 divided by 2 gets me 2 on the outside. That's why there's x squared. And then 2 can go into 5 2 times, which is why there's 2 y's out here. And then I would have 5 minus 4, 1 y left. Okay. Then, my last step, there's an even on the outside of the square root, so we need to make sure that we add the absolute value bars on it to my answer, because there's a 2 that sits out here. Okay, my next one, we're going to go ahead and multiply, so 45 times 35, I get 1,575. X to the 5th times x is x to the 6th. Y cubed times y to the 4th is y to the 7th. So the square root of 1,575 does not go pretty, so I go back. When I look at my squares again, because we're square rooting, which one of these can I divide out of 1,575? So you take 1,575 divided by 225, divided by 196, and see if any of those are pretty, and it is actually 225. So 225 times 7. And then if I want to write out all my x's again, and my y's, this time we're grouping them in 2's. Well, the square root of 225 is 15. I still have the 7 left. I group them in 2's. So I had 3 x's come out, and 3 y's come out, and then I have a y left. Or you could do 6 divided by 2 gets me 3. 2 can go into 7 3 times, so I should have 3 y's out here, and then I'll have 1 y left on the inside. Okay, if these are real numbers and we're dividing, basically what we can do is we can make either a big division sign and divide A and B, or we could go the opposite direction if I have a big division sign and break it so that it's just on the top and the bottom. But again, the ends have to be the exact same on top and bottom for us to be able to do it. So my first step whenever doing these things is to ask myself, can anything cancel and make my life so much easier if it canceled away? Okay, so if I want to make my big square root, because they both are the exact same ends here, we can now simplify. So 8 divided by 2 is 9. X to the 5th divided by x cubed is x squared. There's a 2 that sits out here. And I just realized back on this problem, there's a 2 on the outside, so we need to add absolute value bars. Back to this one. Okay, so now if I'm doing the long way, what when I square it gets me 9? Well, 3 does. 2 times what gets me x? Well, 2 divided by 2 gets me 1, so there's a 1 here. So when I go to do my canceling, 3x is just my answer, but we need the absolute value bars because it was a even number on the outside. All right, my next one, let's do a big one. 162y to the 5th divided by 3y squared. Okay, see if anything cancels. 162 divided by 3 is 54. Y squared, y to the 5th divided by y squared is y cubed. See if 54 can break in a pretty way. It doesn't, because I can't, nothing cubed gets me 54, so we're going to have to go back and figure out what cube gets me to 54. Well, 27 is divisible by, 54 is divisible by 27 there. So 27 times 2 gets me it, and then y. Cube root of 27 is 3. If I group by 3, so a y comes out, or you could say 3 divided by 3 is 1, so there should be one y on the outside, and then I just have a 2 left. It is an odd cube root, so I don't need absolute value bars. Okay, now we're going to talk about how we can't have square roots on the bottom. These ones, we didn't end up with any square roots on the bottom. Well, what if we have a square root on the bottom? Well, we're going to have to rationalize it. Okay, so if I'm trying to get rid of it, I need to multiply by a form of 1, because anything times 1 is going to be itself. So to be able to do that, we're trying to get rid of the bottom square root. If I multiply by the square root of 2 over the square root of 2, square root of 2 divided by the square root of 2 is 1. So that is a form of 1 to multiply by. Well, 1 times the square root of 2 gets me 1 square root of 2. We can multiply the inside because we have the same radicals. 2 times 2 is 4. Square root of 4 is 2. There is now no radical in the bottom. So when I do my next one, I need to get rid of square root of 7. So the form of 1 I want this time is square root of 7 over the square root of 7. Multiply across, so 6 square root of 7. We multiply our insides, so 7 times 7 is 49. Square root of 49 is just 7, and now there's no radical in the bottom. But what happens when there's x's, y's, and z's in it? So my first step in this is, can anything cancel? Well, in this situation, nothing can cancel. So my second step, we're going to be splitting it. So it is now going to be the cube root of 5x squared on top and the cube root of 12y squared z on the bottom. Okay, I need to get rid of the radical on the bottom. To get rid of the radical, I need everything to be in a way that I can cube root it. Okay, so my first step is how can I get 12 to be a cube? So something that I can cube root and it will look pretty. Okay, so if I go back, we're doing cube root. So I'm looking at my cubes. Which one of these is divisible by 12? So that I can get it where I can cube root it. Okay, well 216 is divisible by 12 because 216 divided by 12 gets me that. Okay, so 12 times 18 will get me 216. So I would be able to cube root 216. Well, we got to deal with these y's and z's. So how can I get y squared to become a cube? So what can I multiply by y to get it to be y cubed? Well, y can, because 2 plus 1 is 3. My last one, I need to do z. So how can I get z to be z cubed? Because we're trying to take the cube root of all these. Well, z times z squared gets me z cubed. So I'm going to circle all of these ones that aren't in it that I would need to multiply by to get to my cube root that I need. Okay, so to get rid of my bottom cube root, we need to multiply by these three things to be able to cube root it to get rid of it. So we need to do it to top and bottom. So I'm going to multiply by the cube root of the things I circled. 18yz squared over 18yz squared, a form of 1. Because now when I multiply, so we multiply the top, 18 times 5 is 90, and then I have x squared yz squared. When I multiply the bottom, I get 216, which is what I wanted. then I get y cubed and z cubed, which is what I want, because now what I can do is take the cube root of them. The cube root of 216 is 6. 3 divided by 3 is 1, so I just get a y on the outside. 3 divided by 3 is 1 again, so I just get a z, and now I have no radical in the bottom. So then your next check is the top. Can it be simplified? Can I take 3 x's out of 2 x's? Well, no. Can I take 3 y's out of 1 y? Well, no. Can I take 3 z's out of 2 z's? I can't group any of those by 3, so those are good. So now we just got to check 90. Is there any cube root, oops, too far, that we can divide, so we're looking at cube roots, that we can divide 90 by. So 90 divided by 64, 90 divided by 27, 90 divided by 8. Well, none of them work, so it is completely simplified because nothing cubed gets me 90 and I can't simplify. So this is my answer. Okay, so my last one. First, check to see if anything can cancel. Nothing can cancel in this one again. So my next step is to go into splitting it. So I have cube root of 7x on top and cube root of 5y squared in the bottom. So I'm changing my 5y squared. So 5 times something, and then y squared. So I need it to be cubed. So 5, we're going to go back to our cube roots again. Which one of these cube roots is divisible by 5? Well, 125 is divisible by 5. So if I go back, 5 times 25 gets me to that 125 that I need. Y squared times y gets me to the y cubed that I need because we're doing cube roots. So I multiply this time by the cube root of the ones I circle, so the ones that we're multiplying by that I don't have. So 25y over the cube root of 25y. So I can get rid of, on the bottom, 5 times 25, I got 125, which is, we can take the cube root of. Y squared times y gets me y cubed, which I can take the cube root of. On the top, 25 times 7, 175, and then I have an xy. I can't simplify just an x and a y because I can't group it by 3 for that one. And then for the 175, if I go back, again, we're looking at the cubes. None of them can be divided out of 175. If I divided 64 out of it, doesn't work. 27 out of it, none of them are pretty, so we're just going to leave that as is. So let's simplify my bottom. So I have cube root of 175 xy. The cube root of 125 is 5. 3 divided by 3 is 1. So we just have 1 y on the bottom because we only have one group that has 3 y's in it. So it gets rid of my cube root in the bottom.